This is a research paper that is focused on image and audio captioning. So basically, automated captioning using deep learning, published in multimedia systems by these authors. So the research paper, which is there, implements a methodology to generate captions for the images, which is based upon the background sounds using deep learning. So it uses a mixture of NLP and computer vision. The main focus of this research paper is to combine image captioning of images and sounds and recommend the sounds based upon the captions that are generated. It uses two types of learnings. One is transfer learning and supervised unsupervised. So basically, CNNs and RNNs are used. So CNNs, which are there, they are basically used to process the image, and RNNs, which are there, are used to caption the image, the caption these images. So caption generation. So the model which is there processes an image and directly predicts the captions while it identifies the relevant scenes and combines the visual inputs with the linguistic outputs. So for the RNN approach to basically caption the images, we are using long short-term memory networks. They are so the research objectives basically are to caption the image and the sound for it, use CNNs and RNNs to do so, combine both of these together, and achieve a top accuracy for the sounds and the captions. So they want to combine both of them in the vector form. So the image that is being processed and the caption for the same that is grouped and mapped together. So the algorithm is you have basically been given an image and also you've been given a sound. So you're trying to caption the image and the sound using CNNs and store them in a vector, and then use RNNs to generate the captions on these image, and then suggest the sounds based upon the visual scene that is detected. So you are using CNNs, RNNs, and transfer learning using pre-labeled data sets. So our algorithms, the flow of it is basically we have a training data and a testing data. The training data has the labels, the ground truths, and these are the features of the different images that we have. Our cognitive algorithm is the heart of this whole architecture, where the learning takes place. So basically, features which are there, they are getting mapped with the labels, and we are trying to understand what kind of captions to generate based upon the features of the images. Then this testing data is being used to test what we have learned in the learning phase, the training phase, and a hypothesis is generated, which is a predicted label. So the predicted is then the error is checked with the predicted and the expected label, and it is seen. If it is greater than a particular threshold, then we send it back using the backward propagation and update the weights. So it's in something like this. So the forward propagation for learning, once we understand that there's an error and it is greater than the threshold, we send it back using backward propagation and update the parameters of the weight, and then again train it forward until the error is less than the threshold. These are the results which are obtained using the dice coefficient. The dice coefficient is basically uh, used when you want to check how much is the intersection upon the union. So basically, how much does it relate with the expected data? Is it mapping the expected data? Is it even close to the expected data upon the predicted being close to the expected upon the total data, the points available? So the architecture is basically there is a convolutional layer that is there are multiple convolutional layers that are being used. There is pooling, the softmax as the activation function, and at the end we are basically trying to standardize the result using normalization. So the results are basically the accuracy of 53% is achieved with the top 5 accuracy of 67% for sound and image. According to their studies, they showed that their system, according to them, is the best for class accuracy in three standards, that is acoustic, scene, characterization data set. So the data set that they used was basically the Flickr image data set, which has 12,000 images and their captions. And the audio which was there, audio data that was basically sourced, was from the videos to classify the sounds. The model, then, according to their conclusion, the model successfully combined both the visual and the auditory data with the background sounds. So the system is the first of its kind to combine the image and sound forecasting into the single model. This is what they said. So in the future work, they are going to use it in the real world applications like content moderation and assistive technologies and detect complex visual and auditory interactions.